guys, what's up? Welcome back. In the previous video, we looked at binary search. Today, we're moving on to bubble sort. So, bubble sort repeatedly compares neighboring values and swaps them when they are in the wrong order. So, if you're doing ascending order sort, after each pass, the largest unsorted value moves to the very end of the array. So we'll first take a quick look at the implementation, then the dry run, we'll look at the output, and finally derive the time complexity. All right, let's look at the code. Right here is our bubble sort function with the parameter mylist. It is the list that we're going to sort. And then down here is how we call that function. As you can see in the bubble sort function, we have two nested for loops. So the outer loop controls the passes and the inner loop compares the adjacent elements and swaps. As usual, I have divided the workspace into the three same sections: dry run, storage, and output. Dry run will show what the algorithm is actually doing. Storage will show what the computer is storing it in its own storage. And output will show us the final result. Let's get started. Okay, you can see right here, I have a list L, which has 5 elements: 4, 90, 1, 32, and 10. And then I have a print function, which says my list, and then next line, and then you print out the list L, which is 4, 90, 1, 32, and 10, right? So it printed out this list. Awesome. Then I'm going to move on to my function call. I'm going to say sorted list is equal to bubble sort L. So what this means is my bubble sort function is going to return a list, which I'm going to call sorted list. And I'm sending in the argument L. This L, when we go to the function, is now my list. So my list now has these values: 4, 90, 1, 32, and 10. Here, as you can see, I have my indices set up in a way where we can tell which index has which value as we move along. So in the function, I have my list L, and then I have for I, I have an I in range len my list. So it goes from 0 to length of my list is 5. So in range, it's going to go from 0 to 4, right? One less as usual. Okay, my first value of I is 0. Awesome. Now I have another variable called swapped, right? Okay, I have a variable called swapped and it has the value false. Okay, I understand that. Moving on for J. Now I have a J, and since it's an inner loop, it's going to have multiple passes. So J goes from the range len my list minus I minus 1. So that means it goes from 5 minus I, which is 0. So that becomes 5 minus 1. So that is 4. So J goes in range 4. So that means it goes from 0 to 3. Awesome. So right now, my J is 0. Okay. Move on to the if statement. If my list J is greater than my list J plus 1. So that's my first condition. So my list J is my list of 0, which is 4, is greater than my list J plus 1, which is 90. So you're looking at the current Jth element and the next element to it. So it's checking between 4 and 90. Is 4 greater than 90? No, right? Okay, 4 is not greater than 90, so I'm not going to go into the if block. Moving on, not in the if block, so my J gets updated, so J becomes 1. Now I'm checking for my list J and my list J plus 1. Okay, so now I'm checking for 90 and for 1. Okay, my list J greater than my list J plus 1 is 90 greater than 1. Yes, it is. Okay, so you're true. We're going to swap you. So after swapping, this list becomes 4, 1, 90, 32, 10. Okay. Then swapped becomes true. So swapped becomes true. Awesome. Great. Okay. Next J. So we update J to 2. Now we're checking for 2 and 3. Okay, makes sense. We're checking for 2 and 3. So 90 and 32 are the values that we're looking at. So if my list J is greater than my list J plus 1, is 90 greater than 32? Yes, it is. Oh, great. I'm going to swap you. Since we are greater, I'm going to swap you and the new list is updated. Awesome. The new list is updated. Swapped is still true. Even though it's overwrites, I'm not gonna overwrite it again and again. We're just gonna keep the value true. Okay, update J. J becomes 3. Yay, J is 3. So now we're doing again my list and my list J plus 1. So third value and then fourth value. Okay. My list J is greater than my list J plus 1? Yes, it is. Okay, I'm gonna swap you. So 4, 1, 32, 10, 90. We update J. J becomes 4, which is out of range. We stop the J loop. As you can see, this is my first pass. Cool, right? Now, as you can see in the first pass, the largest element has gone to the very end. That's what bubble sort does. It's going to keep on checking against the adjacent element and keep on moving the biggest element at the end. First pass done. Awesome. Let's move on. Okay, J is over and then I have an if not swapped, break. So not of swap is not of true, which is false. So if false, again, you don't go into the if block, right? If false, I do nothing. Okay, go back up and I update I. I becomes 1. Great, I becomes 1. Swapped is overwritten to be false. Okay, I have overwritten swapped to be false. Now J goes in range len my list, which is 5, minus I. That means 5 minus 1, which is 4, minus 1, which is 3. So it goes from 0 to 2, right? Range 3, so you go from 0 to 2. You do 1 less. Awesome. So this is my jth list range that I have to go into. Okay, my first J is 0 as usual. Get into the if. So I did my if my list J is greater than my list J plus 1. So now I'm looking at these two. My list J is greater than my list J plus 1. So 4 greater than 1? Yes, it is. Let's swap it. Okay, I'm going to swap it. So it's going to be 1, 4, 32, 10, 90. Awesome. Now, since it is swapped, I'm going to convert swapped to true. Okay, converted it to true. And then we update J. So J becomes 1. Great. Now I am checking J and J plus 1. So these two elements. Is my list J greater than my list J plus 1? Is 4 greater than 32? No, it's not. Nothing happens. We move on and we update J to 2. Okay. Now I'm checking 32 and 10. Okay. Is my list J greater than my list J plus 1? Is 32 greater than 10? Yes, it is. We swap it. So now new list is 1, 4, 10, 32, 90. Great. And then swapped is true, which is true. And then we update J. It gets out of the range and we get out of the J loop. Okay, now I have my if not swapped, break. So if not true, so if false, since it's false, we don't break. We go back and finish this pass. So this becomes my second pass. Oh, great. Awesome. So this is my second pass. Now what I will do is I'm going to update I. I becomes 2. Awesome. I is 2. Now j will go from 0 to range len my list, which is 5 minus I. So 5 minus 2 makes 3 minus 1, which makes 2. So I'm going to go from 0 to 1 for this pass. Okay, from 0 to 1. Awesome. So now my swapped again becomes false. Swapped is false. Now j is 0. So again, we're going to do these two elements, 0 and 1. So is my list j greater than my list j plus 1? Is 1 greater than 4? No, it's not. We don't do anything and we move on and update j. J becomes 1. So we compare 4 and 10. So is my list j greater than my list j plus 1? Is 4 greater than 10? No, it's not. We update j to be 2, which is out of our range. So we stop j. And then it says, if not swapped, break. So that means if not false. So that means if true, break. So now that means we're breaking out of the I block. So right here we break, right? We break, and then what we do is we return my list. So the new my list is 1, 4, 10, 32, 90. And this is the list that is returned back to the function call. So now the sorted list is 1, 4, 10, 32, 90. Awesome. And then we have this print function 90. So now we output sorted list, and then next line 1, 4, 10, 32, 90. And that's how the bubble sort works. Now let's look at what happens when the list is already sorted. So here you can see list L is 1, 4, 10, 32, 90. After that, I have a print function which says my list, and then next line, we print out this list 1, 4, 10, 32, 90. Great. And then we have the function call sorted list is equal to bubble sort L. So argument L goes to my list as usual. And then I have this list with all its indices. I have I, which is going from 0 to len my list. So length of my list is 5. You go 1 less, so you go 0 to 4. Okay, and then I have swapped. So I swapped is false for now. And then we have j. And then for this pass, j goes from 0 to len my list, which is 5, minus I, which is 0. So 5 minus 0 is still 5. Minus 1 is 4. So range 4. So 0 to 3. Correct? Awesome. Let's start with j is equal to 0. J is 0. So we're checking out my list j and my list j plus 1. So these are the two values that we're looking into. My list j and my list j plus 1. So is my list j greater than my list j plus 1? No, it's not. Okay. Do nothing. Update j. J is 1. Awesome. So now we're checking for index 1 and index 2. So my list j is 4. Is 4 greater than my list j plus 1, which is 10? 4 is not greater than 10. We don't do anything. We update j. Okay, now we are doing j and j plus 1. So 2 and 3. So 10 and 32 are being checked. Is my list j greater than my list j plus 1? Is 10 greater than 32? No, it's not. We do nothing and we update j. J becomes 3. So now we're checking 32 and 90. So is my list j greater than my list j plus 1? Is 32 greater than 90? No, it's not. We do nothing and we update j. J gets out of the range. So now j is 4 and we have an if. If not swapped, it was not swapped. So swapped is false. So if not false, which means if true, we break out of the I block. Oh, great, we broke. And then I have return my list. So I return 1, 4, 10, 32, 90. So this list itself is returned right here. And then I have a print sorted list. Next line, it's the same list 1, 4, 10, 32, 90. So you see this concept of the flag that we have called swapped. This actually helps us not go through the whole passing set again and again and again. It makes it more efficient. You don't have to run for longer. Okay, move on to time complexity of bubble sort. So time complexity is based on the size of the list. So let's say n is the size of list. Awesome. So we know I goes from 0 to length of the list. So I goes n times, right? And then j decreases each time. So j has, n minus 1 first, because I is 0, so n minus 1. Then I becomes 1, so j becomes n minus 2, and then n minus 3, and so on and so forth till j is 1, right? So that means we are trying to find the sum of n minus 1 plus n minus 2 plus n minus 3 plus 1. And mathematically speaking, this total sum is n minus 1 over 2. Okay, that means this is the amount of time it takes for bubble sort to run through. So this gives me the n squared minus n over 2. Let's remove all the constants and the lower order terms. This becomes big O of n squared. So average case scenario, we have big O of n squared. For the best case though, the reason I showed you the sorted list is that we only go once when the list is sorted, which is n minus 1 time. Again, for big O, for the best case, we let go of the consonants and the lower order numbers. It becomes O of n. So the average and the worst case for bubble sort is O of n squared, and then the best case for this code is O of n. If you do not have this swapped flag situation, the best, worst, and average case will all be n squared because the loop will not stop even if the list is sorted. Keep that in mind and play around with this code as much as you can. There are a few things that you should know about bubble sort. Number 1, remember we are sorting in ascending order. To sort in descending order, you can quite simply change this greater than sign to the less than sign. Makes life easier, and you can definitely run it and check if that works. Moving on, let's look at this swapping, right? So this is an easier way that Python has given us to swap, which is my list j becomes my list j plus 1, and my list j plus 1 becomes my list j. So this is very Python thing. I think other languages do it as well, but since I'm writing in Python, I'm going to tell you this is a very Python thing. So supposingly if you want to swap x and y, you can quite literally do it like this, and it works. Other languages, however, for instance, Java, C++, C, they actually don't swap like this. You'll see a totally different method of swapping. So let's say we're doing it in Java, for instance, okay? In Java, I cannot do x comma y is equal to y comma x. What they do is they use a temporary variable. I'm going to call it temp. And then temp is equal to x is equal to y is equal to temp. Now you're going to ask why go through this weird thing. So here it is. So supposingly I have x, y, and temp, right? So in the storage, x is 0, y is 1. Now I want x to be 1 and y to be 0. So in this storage, what exactly happens is when I do temp is equal to x, it becomes 0. And then x is equal to y. So now this 0 is gone and now x value is 1, right? If I did not have this temp, then I would have done y is equal to x, then y would have been equal to 1, right? But now since I have this temp, I have saved that x value. I can say y is equal to temp and y becomes 0. So this is another way of swapping elements. If you want to do it in Python, you can do the same thing and replace this line by this whole segment of statements and it will still work. Go ahead and try it out and see what happens. That's it. So that's bubble sort. It's easy to visualize. You can detect an already sorted list with the flag we had called swapped. Average and worst case time complexity is O of n squared. Next, we'll look into selection sort, which will reduce the number of swaps by selecting one final value per pass. If you like this video, make sure to like and subscribe and leave on a comment. I'll see you in the next one.